This is Algebra 1, Term 3, Lesson 7. Today we're going to look again at geometric sequences, and we're going to look a little closer at the common ratio and what that looks like in the graph. And students are also going to create their own sequences. They're going to create geometric and arithmetic sequences and compare the two. So let's start in GeoGebra Notes. So this is the task that's in GeoGebra Notes. So when they get in here, there's quite a bit. This assignment is scheduled for 1 to 2 days, and I would say this is going to take most of your first day, probably. Now, the last class period, we actually tore or cut pieces of paper. We're going to kind of continue in that same vein with folding paper. And so to do this task, I do actually give the kids a piece of copy paper. So every kid will have a piece, and I want them to fold it and kind of examine it and see what's happening. I did sort of start the process for them because we're generating an equation, and I want them basically to see the connection between this process and where that's coming from. But beyond that, I don't do too much to help them here. I do want them to work on this themselves. Now, one thing they'll notice in this toolbar is there's lots of tools. So they can use the pen tool, shapes. This is an equation. So they could type an equation, or they can type text here. They can upload pictures or whatever. They can put in links. So they could create a Desmos graph and paste the link to their graph in here if they want to do that without going to this, or they could just put a picture of their graph in here. They also have the option of using the GeoGebra, which I've already opened up for them over here, and I'll show it to you in a second. Creating another table using graspable math. So if they click on that, they could actually do math in here with graspable math. So this is a way cool tool that they have. This is like a virtual whiteboard. And they can just go to geogebra.org/notes and go straight to their own blank canvas to work in. So it's a very nice resource that GeoGebra has made available. So what I want them to do is work on these questions, and when they are done, they will take screenshots. They may need more than one screenshot because, as you can see, I got quite a bit going on here. So let's see if I'm going to use my pan tool here to pull this over. I've given them a copy of a calculator so they can finish this equation down here, and they can actually type in down here the equation. So they can do f of x equals, and they can graph it in here if they want. They can change the window. Since we do use Desmos quite a bit, I can almost assure you there's going to be kids that go, I don't want to do it there. Can I do it in Desmos? And my answer is always yes. Of course, you can do it however you want. So encourage them to play around in here. I mainly just want them to see this resource. We will go back and use it again for future activities, but this is their first exposure. Now, this is a very rich task here. There's so much. First of all, they're going to write an equation, and in the equation, they've got numbers. I want them to tell me what those numbers reveal in this context. I'm asking for the domain of this function. Please note, it says number of folds. So unlike most sequences where we use the term numbers, we're not really doing that here. And then what is f of 7? What does the 7 reveal? What does the value of f of 7 reveal in context? I give them a specific value or a specific output, 8.192. What is that? What does it reveal? What value of x would correspond to that, and what does that reveal? And then the fun. I'm asking them to tell me how many folds it would take for the thickness to reach the ceiling of the classroom, and then to reach the moon, and then to reach the sun. To do those, you may want to give them conversion factors, but honestly, they can Google those things themselves and convert. So I would encourage them to do that. Let's just see what they're capable of here. And that concludes the paper folding activity. When they get it done, I'm just going to tell them to take a screenshot, or more than one if they need more than one to fit it on here, and just get it on here. It doesn't need to be full screen, but I need to be able to see what they're doing. So be sure they insert something here to show what they did in their GeoGebra notes. All right, the next task in our lesson is a Desmos activity. Okay, this task is called a common ratio, and it has 10 slides. if your paper folding activity took a whole day, then this will probably take half a day or maybe a little less. So hopefully you're still on day 1, maybe starting day 2 if you're doing this over 1 or 2 days. So on this screen, they're given a geometric sequence, and I'm asking them to click on these points so they can see the numbers that are in the sequence. And they're going to be doing that on a lot of these screens, so they need to kind of get in the habit. Now, I give them the information here. It's more like a review thing. What function family does the geometric sequence fit? Linear, exponential, absolute value. Good time to review those. You could even stand up and do a quick algebra aerobics. I just saw a cool graphic from the Paris Olympics shared out by Howie Howe about the parent functions and one of the gymnasts and their arms. So you could throw those up and let them decide which of the ones fit this graph the best. It's kind of fun. All right, so now we're into something a little different. We're going to use this fraction bar to visualize a common ratio. So in this case, the common ratio is 2/3. Where do you see that 2/3 in this fraction bar? Take your time on this screen and let them really analyze what they're seeing. You may notice 3 parts in the fraction bar, and that's part of your ratio here, is your denominator is that 3. And then you'll also notice that the right side of the fraction bar, that height of that point is exactly 2 of those little boxes. So 2 of the 3 are on the right side. So that's actually representing your common ratio. I have included common moves and student sample answers throughout this task, so please be sure to check those, especially if you've never really thought about this in that way. All right, now this one we are going to basically do what we're doing on most of them. We're going to click on these points to see what the numbers reveal. So what are the terms of the sequence? So of course you're going to just list out the numbers on the right side. These are the y coordinates. What is the common ratio? So what is it multiplying by? And which fraction bar fits best? Well, if you drag this over, your goal is to get these bars to kind of line up with these points. So you want to go between 2 consecutive points, and you see this one doesn't work too good because this right side is connected to the top corner, but look how this is not really fitting along this line segment that we want. So let's get rid of that one. Let's try the next one. Okay, now this one, if you'll notice, fits really nicely because the right corner is touching this point, and this falls right on one of these fraction bars, right on one of the lines in the fraction bar. So this fits well. There are a couple that have more than one that fit well, because you might have an equivalent fraction if you know what I'm saying. But see, this one does not work too good. So of the 3, we're going to choose the one in the middle. And why would we do that? Well, if you think about it, the numbers are multiples of 3. 3 times 3 is 9 times 3 is 27. So you're multiplying by 3. So 3 parts kind of makes sense since that ratio has that 3 in it. All right, and then this fraction bar, same principle. You're doing this one. Now you could do this one. This one actually works. See how the left side, you've got it at the 4, and then the right side, you've got it at the 2. That works good. But, you know what? So does this one. So there's really not one right answer in this case, but you might have a conversation between the 2. Which one is better? Is there a better one? And why? And the only one that doesn't work very well is this one. This one doesn't work at all. You see, that's not going to work. All right, so once you've chosen that, I've given you some sample responses for this one, so be sure to check it. Then this one is giving you the equation. They really just have to come up with these numbers, so hopefully they know to start with the first term and then put their multiplier in here, and then everything else is done. So I'm not having them start from scratch. By the end of this assignment, we're hoping that most of them get this general form pretty well and can generate these themselves without much assistance from you or their teammates. All right, here's another one. And I'm just throwing this one out there. I would let this sit here a minute before you start saying anything at all. But the goal is for them to choose which of these common ratios makes the most sense for this fraction bar. And so you can get into conversations about, okay, this is growing. And how fast is it growing? You can look at the number of sections in the fraction bar. And then look at the right side versus the left side. The key is to go from the right side to the left side to see that common ratio. Because the right side's where it's going to end up. So for the right side in this case is more than the left side. I'm not going to say any more than that because I do want the kids to think about this without watching this video and just picking an answer. But do read those teacher moves as sample responses. And let this one really sink in before you move forward. So I would probably pace your kids to pause here and let's make sure we get this. Because that is the heart of this lesson. Same here. I've given them an equation. I've intentionally mixed it up. Like I had f of x on one. I had a of n on another one. We're going to have a with a subscript n on another one. So I'm mixing up the notation significantly because I don't want them to think, there's one certain way. We can use lots of different notations to create equations for sequences. And so we're trying to do that. And then on this one, same thing. Notice I used a subscript n on this one. And then finally, they're going to match them up. Now, you'll notice some of these are not geometric sequences, so you may want to talk about that. Are all of these geometric sequences? And how do you know, or how do you know that? These are all, equations are all written with subscripts, but we could have written them as a function, with the function notation. So this last task is pretty simple. I don't think it'll take too long, but the kids should create their own sequence. And the key is I want their sequences, both of their sequences, to have the same first term. But one of the sequences should be arithmetic, and the other sequence should be geometric. And we want the common difference of the arithmetic sequence to be actually the same number as the common ratio for the geometric sequence. And then we're going to basically compare and contrast these two. So their goal is to create the list of terms for both of their sequences. They'll create a graph and an equation for each one. And then they'll compare and contrast, and they could just type here on their slide to do that. So insert screenshots of their tables, their graphs and their equations, and then just compare and contrast. This would make a nice portfolio artifact, but not if they choose exactly the same things as their teammates. So you might want to caution them, if you're planning to use this in your portfolio, you need to go out of your way to try to be something or choose numbers that are different from those you're seeing around you. So if your whole team uses the same two sequences, that's a problem. That would not make a good artifact for the portfolio because we want all of our portfolio to be uniquely ours. So that concludes our paper folding lesson. Y'all have a great day.